Hi GOH, this is Unit 7, Lesson 7, and today we're going to talk about more similarity reasoning. All right, so in exercise 1, they just want us to test out those proportions to see if they're true or not. They're giving a name for the diagonals, but all you have to do is you're going to multiply each of these. So 3 times 3 and 1 times 6. So I'm cross-multiplying. Whenever you have a proportion, all right, the diagonals, when you multiply them, should equal each other. So this one does not equal, so this is false. I'm testing out the truth of each of these fractional equations or proportions. Let's try B. So I'm going to multiply 4 times 15 and see if it's equal to 5 times 12. 4 times 15 is 60, and so is 5 times 12. So it's good. That one's true. And the last one, I'm going to multiply 7 times 15. And I'm going to multiply 3 times 35, and each of these is 105, so yes, it works, it is true. All right, so whenever I take a proportion and I change it into a product, you're basically using this right here, means and extremes. The product of the means, now product means to multiply, is equal to the product of the extremes. Now, which one is the means and the extremes? It really doesn't matter. Technically, because you're just setting them equal to each other, all right? This got mixed up a little bit. I don't know, this got shifted. But the means are the B and the C. Those are your means. And the extremes are the A and the D. So your arrows right there got mixed up a little bit. But you're just cross-multiplying, but now we have a name for those two products. All right, the extremes, A and D are the extremes. The top left and bottom right, and B and C are the means. That's the bottom left and the top right. All right, so let's look at our problem here. In the diagram below, I know that AB is parallel to DE. Well, if these lines are parallel, that means that angle A is congruent to angle D, and angle B is congruent to angle E, because those are alternate interior angles. And then I also know that angle ACB is congruent to angle DCE. So they just wanted us to mark all the angles that are equal in measure. So I did that. I marked them all. So these are vertical angles, and A and D and B and E were alternate interior angles, and that was true because the lines were parallel. Which two triangles are similar? How do we know? Write down a similarity statement. Watch the order of your vertices. All right, it's helpful to redraw the two triangles. So we can absolutely redraw them. So I'm going to draw that ABC. So A, B, C. So A had one little arc mark, B had two, and C had the three. And then I'm going to draw the other one. Now D goes here, E goes here, because look, D had one little arc mark and E had two. And then the C is up top. So there it is. I redrew them. So basically, triangle ABC is similar to triangle DEC. That would be the order, right? The order of the vertices tells you which of the angles are corresponding or matching up to the other one. Now they want us to write down a reason for each of the following statements. BC over CE. So basically, I am taking BC, which is this side right here, over CE, all right? And I'm writing them as a ratio, and then AB over ED. Why is that true? Well, because the triangles are similar, therefore those corresponding sides of similar triangles are in proportion. So the corresponding sides of similar triangles are in proportion. So once I prove that the triangles are similar, I now know that the corresponding sides are in proportion. What's going to happen is this is going to be an extra step that we add on to a proof. So after I prove the triangles are similar, I can say the sides are in proportion. So it's sort of similar to when we did that CPCTC in our congruent triangle proofs. And then after I say the sides are in proportion, I can cross multiply, and CE times AB is equal to BC times ED. And the reason for that is the product of the means equals the product of the extremes. So when I'm doing a proof and I prove that my triangles are similar, I can then say the sides are in proportion and set up a proportion, and I can then say that I can cross multiply. So I just have those products. Products of the means equals the products of the extremes. So let's see how this looks in an actual proof in exercise 3. Again, it's really similar to when we use CP/CTC for our congruent triangle proofs. All right, and I even wrote that. These types of proofs are similar to CP/CTC proofs from congruence work. We'll see them often in the rest of this unit and in a unit on geometry of the circle. All right, so I basically want to prove that those sides multiplied, mn times mr equals mq times mp. First, I have to prove that the sides are in proportion, and before that, I have to prove that the triangles are similar. So you're basically proving the triangles are similar, then you can say that the sides are in proportion, then you can cross multiply and tell me that mn times mr is equal to mq times mp. So in this triangle, the two triangles I have here in exercise 3, I know that NP is parallel to QR. So these are parallel. If they're parallel, then angle 1 and angle 2 are congruent. Those are corresponding angles. And angle 3 and angle 4 are congruent. Those are also corresponding angles. So angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Corresponding angles are congruent. All right, and I have angle. Now, it's also true that they share angle M, so I can say angle M is congruent to angle M, but I don't need to do that. I have two angles, and that's all I need. So triangle MNP is similar to triangle MQR. And the reason is angle. Now, once my triangles are similar, I can then say my sides are in proportion to one another. All right, so I know the last step, which is when I cross multiply. So I can sort of use that last step. This last step is the product of the means equals the product of the extremes. You could also just say, since the triangles are similar, the sides are in proportion, and you can cross multiply. Product of the means equals product of extremes. Now here I have to say what that ratio is, okay? Because if the triangles are similar, the sides are in proportion, so I have to come up with that proportion. All right, so I'm going to say MN and MR. All right, because see how I'm going to multiply them, and I get that right there. And then I'm going to say MQ and MP, because again, I'm going to cross multiply and get that. Now, the reason that's true is because I know the triangles are similar, and the corresponding sides of similar triangles are in proportion. So corresponding sides of similar triangles are in proportion. There is no short little CP/CTC thing to write here. The corresponding sides of similar triangles are in proportion. Okay, so I prove the triangles are similar by angle. I say those corresponding sides are in proportion, so I write the proportion, and then I can cross multiply, and I say the product of the means equals the product of the extremes. We're going to try another last question dealing with altitudes, okay? So an altitude is a line drawn from the vertex of a triangle perpendicular to the opposite side. A particular thing happens when you draw the altitude from the right angle of a right triangle. All right, so given triangle ABC, so that's this big one right here. Triangle ABC is the outermost triangle. It happens to be a right triangle. The right angle is at ABC, and altitude has been drawn to the hypotenuse. So the hypotenuse is across from the right angle, and this line right here happens to be an altitude. Explain why triangle ADB must be similar to triangle ABC. All right, so ABC I have highlighted or traced out in orange. I want to know why this triangle right here is similar to it. Now remember, to be similar, I just need angle, angle. Well, both of those have a right triangle, okay? They both have a right angle, so that's 90 degrees. Those have to be congruent. And they also both share angle A. Therefore, they are similar by angle, angle. Okay, so the outermost triangle, ABC, that I have in orange, and the one I just highlighted in yellow are similar to each other because by angle, angle. They share angle A and they both have a right angle. All right, draw triangle ADB and ABC so it has the same orientation as ABC. So I'm going to take ADB and I'm going to redraw it. So I'm taking the one, I'm going to highlight it in yellow too. The one that I have highlighted in yellow up there, and I'm redrawing it. Now when I redraw it, the right angle was at D, so this is D. A is going to still be here at the top. I want it to be in the same orientation, and they share angle A. And then therefore B has to be here. So basically that triangle, besides they're similar, so there was a dilation, but it was also rotated and reflected. Now, we don't need to write a real proof, but remember these two are similar to each other, therefore their sides are in proportion. So since triangle ABC is similar to triangle ADB, that's what I set up above, by angle, angle, then their sides are in proportion. So let me take the two sides. So let's take the hypotenuse of the bigger triangle, the one I have in orange, which is AC. I'm going to take the hypotenuse of the smaller triangle, AB. Let me grab a color just so you guys can see this. So I'm taking this side right here, the hypotenuse, and this hypotenuse. Okay, and then I'm going to take AB, which is the left side, and that is equal over AD, which is the left side. All right, so I'll do that in green. Then I'm taking this side and this side. Now, if I was to cross multiply, I would get AB times AB, which is AB squared, and I'd get AC times AD. So there you go, I proved it. I said they're similar by angle, angle, therefore their sides are in proportion, and therefore if I was to cross multiply, that would be true. Okay, and we will practice all of this tomorrow.